Welcome back to another detailed Arduino tutorial video. In this lesson, we will explore the passive infrared motion sensor. We will go through how it works, its pin layout, and how to adjust both sensitivity and timing. So, what is a PIR sensor? PIR stands for passive infrared sensor. It is called passive because the sensor does not emit any energy and it only detects energy emitted by other objects. These sensors are commonly used in security systems and automatic lighting systems. For example, if lights turn on automatically when you enter a room, that system is using a PIR motion sensor. Now let's see how PIR sensor works. A PIR sensor detects motion by measuring changes in infrared radiation. It does not emit energy. It only detects heat differences from objects like humans or animals. At first glance, it might look like a simple module, but inside it actually has a pretty smart working system. Let's start with the top part, which is the Fresnel lens. This is one of the most important components of the sensor. It collects infrared radiation from the environment, and instead of focusing it on a single point, it divides it into multiple zones. So basically, the sensor doesn't monitor just one area, it monitors multiple segmented zones. Right below that, we have the PIR sensing element. This is a pyroelectric sensor, and this is where the real detection happens. It doesn't measure temperature directly, and this is very important to understand. It only detects changes in infrared radiation. So if something stays still, the sensor doesn't really care. Moving down, we see the signal processing circuit. This part takes the tiny signals coming from the sensing element, amplifies them, filters out noise, and converts them into a usable signal. In other words, this is the part that generates the digital signal that we can read with something like an Arduino. And finally, at the bottom, we have the pins VCC, ground, and out. Out pin is the most important pin for us, because when motion is detected, this pin goes high, and when there is no motion, it stays low. To understand how a PIR sensor actually detects motion, we need to look at its internal structure and logic. First of all, the sensor's detection area is divided into two main zones, usually called Zone A and Zone B. These zones constantly monitor infrared radiation coming from the environment. Every human body naturally emits infrared radiation, typically in the range of 8 to 14 micrometers wavelength because of body heat. So what happens when a person moves? As a person walks across the detection area, they don't stay in one zone. Instead, they move from Zone A to Zone B or from Zone B to Zone A. And this movement causes a change in the infrared levels received by each zone. For example, when a person moves from Zone A to Zone B, the infrared energy in Zone B increases compared to Zone A. And when the movement goes the other way, from Zone B to Zone A, the infrared level in Zone A becomes higher and Zone B becomes lower. Let's go step by step through the working logic. When there is no motion, both zones receive stable infrared radiation. There is no change, so the sensor output stays low. But when a person starts moving, for example from Zone A to Zone B, the sensor immediately detects an increase in infrared in one zone and a decrease in the other. This imbalance is interpreted as motion, and the output becomes high. Even if the person continues moving slowly, the sensor still detects these changes and keeps the output high as long as motion continues. Finally, when the movement stops, the infrared levels become stable again. Since there is no longer any change between the zones, the sensor waits for a short delay and then returns the output back to low. So, in summary, a PIR sensor doesn't see motion directly. It detects motion by analyzing changes in infrared radiation between two sensing zones over time. Now let's talk about those two little knobs on the PIR sensor, because they actually control how the sensor behaves in real life. If you've ever looked closely at a PIR module, you'll see two potentiometers and you can adjust them using a small screwdriver. Each potentiometer has a very specific job. First one is sensitivity adjustment. This knob controls how far the sensor can detect motion. Think of it like this: when you turn the sensitivity up, the sensor can detect movement from farther away. When you turn it down, it only reacts to motion that is closer to the sensor. So for example, if you're using it in a room, you might want higher sensitivity so it can detect someone as soon as they walk in. But if you use it outdoors, setting the sensitivity too high can cause issues. Environmental factors like heat waves, sunlight, or even minor movements may trigger it by mistake. In that situation, reducing the sensitivity helps you get more reliable and stable performance. Second one is time delay adjustment. This one controls how long the sensor stays active after detecting motion. In other words, how long the output stays high. If you increase the time delay, the sensor stays high longer. If you decrease it, it returns to low state more quickly. Let's say someone walks in front of the sensor with a long delay. Even after the person leaves, the sensor will keep saying motion detected for a few more seconds. With a short delay, it will quickly reset back to low. These two settings work together and completely change how your system behaves. High sensitivity plus long delay detects motion from far away and stays active longer. Low sensitivity plus short delay only detects nearby motion and resets quickly. Be careful with extreme settings. Too much sensitivity can cause false triggers, and too short delay might miss continuous movement. So, in simple terms, the sensitivity knob is basically asking, how far should I detect motion? And the time delay knob is like saying, once I detect something, how long should I stay active before turning off? In the widely used HCS of 501 PIR sensors, the potentiometers allow you to adjust the detection range, typically between 3 to 5 meters, and the continuous output signal duration from about 0.3 seconds up to 5 minutes. Now let's take a closer look at this jumper right here on the sensor. This small yellow piece is actually very important because it controls how the sensor triggers the output. You'll see two positions here, L and H. If you place the jumper on the L position, the sensor works in single trigger mode. So basically, when motion is detected, the output goes high, and it remains high for a certain duration. Even if there is more movement during that time, it doesn't extend the signal. Once the time is over, it goes back to low. If you move the jumper to the H position, the behavior changes completely. This is called retriggering mode. In this mode, as long as motion keeps being detected, the output will stay high. Every new movement resets the timer, so the sensor keeps the output active. So, in simple terms, L means one-time trigger, and H means continuous triggering while motion is present. This small jumper completely changes how the sensor behaves. Choosing the right mode is especially important in applications like alarm systems or automatic lighting. In this tutorial video, we covered all the essential basics about the motion sensor. In our next lesson, we'll meet again in our burglar alarm system project.